Hi dears, today we can see some MCQs related or line integrals and complex analysis. The first question, the complex line integral is, option A is right, dependent of path. Second question, let C be the curve integration, L be the length of the curve and modulus f is less than or equal to m, then the complex line integral is. Option A is right. Modulus integral over C f is less than or equal to ml. It is ml inequality theorem. Now the third question. If f is analytic in a simple connected domain D, then indefinite integral exists. The same question. Differentiation is also exists. So here indefinite integral exists. Now fourth question, the integral over c z minus z naught the whole power f dz is equal to. You can see among the four options m equal to minus 1 is common. So while substituting here integral over c z minus z naught the whole power ms minus 1 dz. So which gives 1 divided by z minus z naught into dz. So here represents circle C. So modulus z minus z naught is equal to radius r. That is z minus z naught is equal to the polar representation r e power I theta. That is z is equal to z naught plus r e power I theta. Now differentiate. This is a constant. And here with respect to theta, so r e power I theta into I d theta. Well, substituting this to here, so integral over c 1 dz. Dz is r e power I theta into I d theta divided by z minus z naught is here r e power I theta. Here c is the circle, so the range is 0 to 2 pi. R e power I theta is cancelled, which is equal to I integral d theta is theta from the limit 0 to 2 pi. So the answer 2 pi I is right. So option B 2 pi I for m equal to minus 1. Now the fifth question, the value of integral over c z cube minus 6 divided by 2z minus 1 into dz is. So you can see integral over c z cube minus 6 divided by 2z minus 1. For that, if you take 2 outside, z minus 1 by 2 into dz. So which can be written as integral z cube minus 6 by 2 divided by z minus 1 by 2 into dz. So we can find the integral using Cauchy theorem or Cauchy residue theorem, whatever. So here I am using Cauchy residue theorem. So the Cauchy residue theorem is integral over c f z dz is equal to 2 pi I into summation of residues. So we can find the residue. So for that the point is here z minus 1 by 2. So the denominator equated to 0. So z minus 1 by 2 equal to 0. Z equal to 1 by 2 is a symbol pole of order 1. So we can substitute in residue z tends to 1 by 2 into fz. That is equal to limit z tends to 1 by 2 z minus 1 by 2 into the value here fz. This is the value of fz. So fz is z cube minus 6 divided by 2 divided by z minus 1 by 2. So these two get cancelled. Apply the value z tends to 1 by 2. So that here you will get 1 divided by 8 minus 6 divided by 2. Now we can substitute this to the Cauchy residue theorem. Here we can substitute it. So that integral over c, the question that is z cube minus 6 divided by 2z minus 1 dz is equal to 2 pi I into summation residue. So summation residue is now we found this, that is 1 by 8 minus 6 divided by 2. You can cancel this 2, so that we are getting the remaining is pi I into 1 by 8. That is, you can see option D, pi by 8 into I minus 6 pi I. So option D is the right one. Next question, sixth one. The function f z equal to 1 divided by z power n is. So if you substitute z is equal to 0 here in the denominator, you will get that's equal to infinity. So the function is not analytic. So this is equal to infinity, that means the function is not analytic, means we can say that is singularity. So it is singularity at z is equal to 0. So option B is right. Now seventh question, the function f z equal to sec z is. So the function f z equal to sec z is 1 divided by cos z. So out of this you can substitute z is equal to pi by 2 at first. Whether it is analytic or not analytic, we can show that. So 1 divided by cos pi by 2, which is equal to 0, that gives infinity. So f of z equal to infinity means that is not analytic. So here it is not analytic, z is equal to 1 by 2. If you put z is equal to pi, it has the value as minus 1. 1 divided by cos pi minus 1. So it won't get infinity. So it is analytic one. So option C is wrong. But here if you substitute z equal to pi by 2 gives infinity. So it is not analytic. So option B is right. Now eighth question. If an entire function fz is bounded in absolute value for all z, then fz is equal to constant. Entire function means it is analytic. Analytic function is bounded in absolute value for all, then it is constant. This is the statement of Liouville's theorem. Next question, ninth one. If fz is continuous in a simple connected domain and if integral over c fz dz equal to 0, then option B fz is analytic in T. This is converse is also true. If it is analytic and continuous, then integral over c fz dz is equal to 0. Now 10th question. If fz is entire, then fz is analytic for all z. 11th, every power series represents analytic function and every analytic function represented by power series. So here both A and B are true options. Now the 12th question, for second order zeros. For simple pole, you know that fz is equal to 0. You will get some value and it is of pole of order 1. So for finding the second order 0, the option B is right. That is the function at f dash, if you find that is equal to 0, but f double dash, the double derivative shouldn't be equal to 0. If so, we can say that is second order 0. 13th one, a Maclaurin series become a Taylor series with the center z not equal to 0. That is z minus z naught, in this place is equal to 0. Then 14th one, fz is entire function, then the Taylor series is converges for all z. We know that the Taylor series is also a power series. So according to that condition, we can say that it is convergent for all z. Then we can see some results here. Cauchy integral formula is f z naught is equal to 1 divided by 2 pi I integral over c f z divided by z minus z naught into dz. The extension of Cauchy integral formula is f n dash of z equal to or z naught equal to n factorial divided by 2 pi I integral over c f z divided by z minus z naught the whole power n plus 1 into dz. If you substitute n is equal to 1 here, we can see that fz divided by z minus z naught the whole square into dz, which is equal to, it will be moved here, so 2 pi I divided by 1 factorial into f dash of z. Such a way we have to find it. Now the Morera's theorem, fz is continuous in a simple connected domain and integral is equal to 0, continuous, and this is equal to 0, then we can say that fz is analytic in T. This is the Morera's theorem. Liouville's theorem is fz is an entire function and also bounded, which has the constant value, then we can say that fz is constant. Then Cauchy inequality, if modulus fz less than or equal to m holds for all z and the function f is analytic in C, then modulus integral f and dash of z naught less than or equal to n factorial m divided by r power n or n equal to 1, 2, 3, etc. Thank you.